So yeah, over to you, Rahul. Let's talk about Metaflow at Adept.
Yeah, sounds good. Good morning, everybody, or good evening, good afternoon, wherever you are. Give me a second to just make sure y'all can see the slides. Let me know if that works.
Yep.
Perfect. Cool.
Yes.
If there are any questions, just hold me up because I cannot see that chat right now. Awesome. Hey, everybody. My name is Rahul. I work at Adept in the infras team. And today I wanted to talk to you about how we've been using Metaflow in combination with Argo on Kubernetes.
No, that's okay.
So I spoke about
I'm sorry?
static and dynamic created image test.
I think
So they
Hey. Okay.
Yeah.
He's muted.
All right, got it. Thank you. And so today I'll be talking about how Metaflow and Argo, we're using Metaflow with Argo on Kubernetes for some of our fine-tuning pipelines and also monitoring infra. Cool. So if you guys haven't heard about Adept.ai, it is a new way to use computers. We are building a machine learning model that can interact with everything on your computer. So on the right, you see one of our older demos from last year, where there is a small extension that sits on top of your browser, and you can see it as you type it instructions. It is operating and making the changes to the sheet to create these profit columns and whatever you're asking, it's just doing these activities for you. And so as you can see, it could easily become a complex task. Different websites have different ways of laying out their websites, and there's a lot of things to do here, which is why you need a very strong model to be built that can solve this directly. You can't typically use an existing model that's been there outside already. And so to do this, initially where we started was we were using Slurm. So at Adept, training, fine-tuning, and development nodes workloads kind of run on Slurm. And Slurm has been around for ages. It's super easy to use once it is set up. You have a bunch of commands that you can see over here to queue your jobs, run the job that you want, or run it asynchronously. You can specify how many nodes to run it on and so on. And if you can think about like how distributed training works, it kind of fits the pattern, right? You can just say, hey, launch this job, or I have a Python file, launch it on 16 nodes, each node having 8 GPUs. So that's 16 times 8 kind of number of GPUs kind of thing. And so Slurm is a open source, fault-tolerant, and highly scalable cluster management and job scheduling system. And for the longest time, this was great because the developers just get a node on top of Slurm, and then they can launch their fine-tuning and training jobs. And it seemed to be working really well for the initial days at Adept.
And just one quick question here, Rahul. So Slurm has been around, for the longest time since the HPC days. So it's not specifically meant for machine learning and AI, but of course it fits the use case very well. Is that right?
Yeah, and so when you go to a cloud vendor right now and say, hey, I need an HPC, I need a cluster for doing machine learning models or building foundational models, they'll give you an option. They'll say, hey, do you want it with Kubernetes? Do you want it with Slurm, right? And then you can go and choose what you want and use it. So it's more as a offering that, the big companies provide when you want, let's say 200, 300 nodes, each having 8 GPUs, like they're going to give you either a Slurm or a Kubernetes cluster. Excuse me. And so the problem that the data scientists here were facing was, creating these self-serve fine-tuning pipelines where you could change around the steps was getting too complex. So on the left side, in the ideal world, you would just have one entry point. You use some libraries such as Fire to just launch the training, fine-tune, and eval flows. But in practice, what was happening was, and depending on who came in at what time in the company, there was a training file that loaded a config, which might have some hyperparameters, set some logic, and then call the Slurm sbatch command to run the job. In fine-tuning, you have another different config file, and then if the data was in some way, you do some processing and run that job. And then somebody came up and said, hey, what we actually want to do is nightly fine tuning and eval. So let's have another config file, do nightly, check whether the nightly config was successful. If yes, then run it to an eval, send it to an annotation partner to get the evaluation done. And by the way, just run all of this on Slurm, right? So for the longest time, this kind of was existing, and it started becoming really hard for anybody coming in new to make changes to, because the code started getting too complex, right? And in the meantime, a lot of the I'm on the left-hand side right now, which is a lot of the developers and data scientists wanted a more flexible alternative to Slurm. For a lot of you might be hearing about Slurm for the first time, and that's true with many people who start working on this fine-tuning models. Start working on foundational models and things like that. And so people wanted a flexible alternative to Slurm that is more prevalent and has a lot more online resources, and that's where a lot of the developers who had some experience said, "Hey, why don't we try migrating our workloads like training, fine tuning, eval, inference, CI/CD, and dev boxes to Kubernetes, right?" And naturally, as part of solving this problem and making it easier for everybody to fine tune and build models faster, increasing the velocity being the highest goal, we were investigating what are the different alternatives we have for creating workflows. And so we investigated like about 4 of these. I've listed 2 of them out, which were on top of Kubernetes, or at least Metaflow in comparison to alternative. And so, with Metaflow, one of the things we really liked was it was using Argo as a workflow orchestration system. Even though Metaflow supports AWS Patch, because we wanted to do more stuff on Kubernetes, Argo being a very robust, battle-tested workflow orchestration system, we wanted to use Metaflow with this. The alternative has their own custom orchestration, and it might be great, but from a design perspective, we were more comfortable choosing the first one. And most alternatives support both pipeline decorators and managing and launching pipelines in the UI. So there's almost all feature parity, but then some or the other, you have to make a design decision based on weighing what the best stuff, what is the best thing for you. So we chose Metaflow because it used Argo for the workflows, and Argo is battle tested. So, we were at a place where we're like, great, we've picked up our library we want to do workflows in, we can containerize everything and launch using Argo. Great, right? Well, no. It happens that there are there were many challenges that we had to go through, and some taking months. Challenge number 1 was that the code was too complex, and the config files that I showed in a couple of slides before were in multiple locations, right? So it took us about a couple of sprints to untangle the code into hey, what are the logical steps that we can plug into the steps approach of a workflow in Metaflow, and then also make sure that there is a consistent config loading once Metaflow containerizes the Python files, as well as the rest of the code which we want to execute. And so it was slightly challenging because of the way the containerization happens. But we were able to find out, we were able to use Python paths to environment variable to make sure that the Metaflow code found the right config files. Code. I'm sorry, somebody is not on. Is there a question? Awesome. Challenge number 2 was that our code, which is the actual fine-tuning stuff, still runs on Slurm. And for good reason, because it is supporting the data scientists right now. They are training models nightly. They are training models up, and even updating the flagship models whenever there is enough progress made on the model. And so we wanted to keep supporting that without having to say, hey, it's going to take some time, let's just switch everything to Kubernetes. Because, as I explained, the code was complex. And so the approach we chose here was Metaflow flows will be the orchestration system, and each step will SSH into the Bastion node on our Slurm cluster, and runs the srun command to actually do the execution. So it was like, hey, temporarily we're going to have a middle ground wherein we are using some stuff on Kubernetes and some stuff on Slurm, but what we really want to do is to run fully containerized workloads on Kubernetes. And that is a work in progress. It's been a few months that we've been doing this, but without compromising on velocity or having people slow down. The third challenge was the containerization was slightly challenging because the code repo was large, and that came in from some initial attempts at using Git LFS for some storing some versions of the models or some data inside the code base, and that bloated to like almost about a GB. When we want to run a particular, like let's say you're a data scientist who makes some change locally and they want to run fine tune on that particular change that they have done, you want to commit the code, get the commit hash, and run everything at that code, right? Especially inside a container using Argo. And so in order for everything to work nicely, we had to bring it, like reduce the size of the code, remove all the data, remove all the dead code, and so on. But another interesting thing we did from GitOps, is every time you have a commit, we build a container. So that container contains all our, library dependencies. We start with, like, let's say a PyTorch or an NVIDIA PyTorch container and build on top of it so that it has all the libraries we need and so on. So we kind of had to do some of this ourselves, even though, Metaflow's packaging system does take care of it. We had to do it because a lot of our code was the dependencies were not easily packageable directly. And the last one, yeah. Sorry,
quick question here also. You mentioned earlier that basically like every step in a flow was going to SSH into a bastion and then run the slurm srun command.
Yeah.
So as such, each step, the Docker container required for each step could have been fairly small, minimal, right? As long as it can do SSH, it's good, right?
Right, but that's not the end goal, right? The end goal is the
I see
workload. So I'm now moving towards like, how are we doing this part?
Got it. Okay.
This, you're right. Okay. It needs a simple busy box container.
Correct.
Right?
Got it.
Rahul, another follow-up question on that end. So what are the kind of changes that the data scientists are making? Because if, let's say, those are just code changes that they're making, then you could still rely on Metaflow's code packaging and still have sort of like a broader container that has been baked with all the packages and dependencies in there.
Right. And so the way we had a middle ground was the code about the flows is packaged by Metaflow. So workflows is what are the workflows? What is the ordering of the nodes? What does the DAG look like? That is done by Metaflow. But the rest of the package, because we had some legacy code that couldn't be touched in ways and couldn't just be like, if you were starting from scratch, we'd do it differently, right? But because of the legacy code, we just had to use an approach wherein the container, when it is built, is installing all the requirements that different data scientists need and is able to use it. Also, it's not just we are considering Kubernetes for workflows. We also want to support dev boxes. We also want to support CI/CD. We also want to support training with gang scheduling on Kubernetes, right? So it is a holistic approach we are taking to containerization. So just have one container and do it differently. If the only thing we wanted to do was just run Metaflow, then we would have probably chosen a different approach.
Yeah, makes sense.
Right. So again, from an architecture, I come in on the architecture side. If I want to enable all of these workflows and not just all of these workloads and not just workflow, the design decisions I would take would be different.
Got it.
So the last part was the last challenge was like, how do we allow multiple people to create the self-serve access? So fortunately, we had the people figured out how to connect these flows together with decorators. There was obviously the UI, which shows people how their jobs are running and so on. And also, we created an internal Adept CLI, which allows people to launch jobs without having to
Argo workflows create, yeah.
Yeah, Metaflow Argo workflows create. Sorry, that took me, the ordering took a little time to get there. So yeah, it creates those workflows so that every time there's a merge on main, we can do some update our nightly workflows automatically. So I think the CI/CD is super cool when you start updating your workflows automatically. And then apart from fine-tuning and eval, we are also monitoring infrastructure because we are still on Slurm. We have to do that. Kubernetes, you have other infrastructure management stuff. And this example just shows on the right, monitoring all the Slurm jobs that are running so that we know, if there's a long-running job or a zombie job, we can track that. So we monitor Slurm jobs, detect long-running workflows, detect zombie workflows, completed workflows, and so on. And we can, and just because I know that I've been taking a while, we also do some housekeeping tasks. So, for example, we check what are the long-running workflows. We also clean up the workflows that have completed a while back, and so we also using Metaflow to trigger our housekeeping jobs. So to conclude, Metaflow plus Argo on Kubernetes works well. The wins were users can launch fine-tune jobs self-serve. Argo workflows is very robust to handle battle-tested way Kubernetes on top of Kubernetes. We have some autopilots, which are like infra monitoring and nightlies, which Metaflow and Argo allow us to do. What is in work in progress? Moving workloads directly on Kubernetes. Fine-tuning and training on Kubernetes is a big challenge, given the size of our containers. We want to do more CI/CD for our nightlies on merge on main and recreate when workflows are updated. Some of the desired features, though, from the system are exception handling at a step level. So we already, I think, have exception handling at the job level, but we wanted it, or the workflow level, one at step level would be cool. Queues for flows if resources are not available. So sometimes somebody launches like a 32 node job and we don't have 32 nodes right now, and that crashes. So we need to have some way of queuing our flows. And also some have one workflow create and launch another workflow in a parameterized way. That's another desired feature. So that's it. Sorry, I took a little bit more time. We are hiring. You can go to Adept.ai and careers, and this is a bunch of roles. If you know somebody who's there, share the word. And for this crowd, you'll notice that there's some infrastructure team is hiring as well. That's it.
Awesome. I mean, this is like, I love the comprehensive nature of the use of Metaflow. It's there for like everything from fine-tuning LLMs to monitoring to like actually looking at the Slurm jobs and what are there and not there. Very cool. Very, very cool. Thank you so much, Rahul. This was awesome.
Yeah. And thanks for having me. It was great. And I also wanted to give a shout out to Shri and Savin. So initially, when we started working, Shri and I, we talked like, hey, is this the right approach? And what ways could Metaflow be used? So there was definitely some support that was well received. And thank you so much for helping us out.